This conference will now be recorded.
I'm looking for other people to join. Sure. What happened to others? The error from my end or someone? Okay. Hope my voice is clear now without it gets disturbance. So what I'm asking here is, yeah, what I need to do if my values are like this. If my target variable is 0, 1, what we were actually done in your machine learning concepts, okay, where this thing is like this. My inputs are calculated with the formula of linear algebraic formula, and we are calculated these values in the form of like this. All right, but what is my result here? Y is equal to 0, 1. So in order to convert these values in the form of 0, 1, what I have done in machine learning concepts? That's my question. What I have done in my machine learning concepts? Is my question is clear, or you are not able to recollect it? No, in this sense, question is not clear or not able to recollect. No, for what? Not getting the question. Oh. See, listen again. This formula, you remember your linear algebra formula? This is what I used, right? Then after using those formula, we are able to calculate this equation or not. We are able to calculate this equation values, whatever 20 plus 31 into x1 plus 32 plus x2 something. If my target variable is in this nature, okay, and my values are in this formation, so what I have to do to get these values from where? To get these values, to get these calculated values in the form of 0, 1. That is what I am asking. To convert these values, okay, in the form of 0, 1, what I have to do? Scaling, not scaling. You are forgotten. We applied a logit function. That is how logistic regression will form, na? Huh? You are telling scaling. You should tell that exponential. So what I have done, e power beta x. Yesterday I think you have told. This is what we have done or not. This entire function is what called logit. If I apply this logit there, it will be converted into 0. So what do you call this one? A function of logit. whatever the function name is logic, but it will be called here as what? A function. Similarly, in support vector machine, okay, what functions that we have applied there? Radial basis, polynomial. Able to recollect? Linear also, yes. So linear, it won't look any change if you apply linear, but yeah, you can consider as a function. All right. So here also, to convert my actual x values to my y values, I need to suppose apply a functions. That is what this activation function. Here I mentioned yesterday also. Oh my god, yesterday also I talked about this one. See, this thing is I told or not. This entire thing is what called a summation. The entire mathematical matrix calculation, that whatever we are going to do is called as a summation. And this after applying this summation, you are passing an activation function. I'm talking about logic in previous concepts. Now in these concepts, we have something else. That is what I would like to mention here. Okay, this is, I don't know why I mentioned it. All right, now come back. So what are the functions that we have here? So this logic will be called here as sigmoid. This logic will be called here as what? Sigmoid. Like that, we have ReLU. Okay, let me open my page. I told you the next page of okay. Never told me. Things are very slow today. In between this gap, I can express some more things. So let's recall. So what this thing here, it is called as input layer and output layer, and it will be creating a hidden layer between. Okay, so in between that hidden layer, you will do several operations that we'll talk later. And here, yeah, one is ReLU, another one is threshold function. Okay, another one is hyperbolic tangent. Hyperbolic tangent. Okay, like that. Not only this, there like that, lot of functions are there. almost 10 functions are there. So I'm not writing it all because the most important things that we are making use here is your sigmoid and ReLU. Your sigmoid and ReLU. Why? Because it is worthful to use for us here. So in different situations, you can adopt some other functions as well. Let's not worry about those things because the entire mathematics will come into the picture here. That I don't want to take. Okay. So and you will also feel bored of too much of talking about different mathematics things here. So what sigmoid will do? It will convert your values into 0 or 1. What ReLU will do? Here the thing is, it will be like this: max of your actual value or your 0. So what does it mean here? If your values comes out with a resultant as negative, it will be takes, if it is negative, okay, it will takes only 0. Otherwise, that means otherwise means what here? If it is a positive value, otherwise the same value. Suppose my input is -10. Okay, if I am applying a ReLU function on -10, so my answer should be 0. If my input is a 10 and if I apply a ReLU function, my answer should be still 10. Is it clear? That means what? ReLU will do what? Always greater than or equal to 0. That means greater than or equal to 0. 0 to somewhere the value what you are taken as input. If your input is 1 lakh, so your output should be 1 lakh. If your input is -1 lakh, your output should be what? 0. It always converts negative values to positives. It always converts your negative values to positives. It won't allow to take negative values. So why will get negative values? That's the other question. Depends upon what kind of data set that you are taking. Like that, many things will be there. Clear about till here? So where do this will apply? That will talk. That will talk later. Where it will apply? We'll get to know. Okay. So now come back. I thought the page will get opened, but it's not getting open. Okay. Let me explain few more. So if we write neural network architecture, neural network architecture. So how this is going to be formed? So always one contains input layer, second one hidden layer, third one output layer. Okay. So the question is, how many neurons will be there in the input layer? How many neurons will be there in the input layer? For example, it will be like this. I'm just trying to think how to draw the picture. So your input is like this. X. So here contains of 3 variables. That means 3 places are occupied. All right. So here, imagine you have 100 rows into 3 columns. Your dimension of this input is 100 rows into 3 columns. Okay. And what you have to supposed to do? Yeah, your target variable somewhere around here is a y values. So let's imagine that your y is the classification. Your y is classification. So your result will be contains of only what? Target variable contains how many columns and how many rows? Only one column with 100 rows. Agree? 100 rows with one column. And so this one contains what actually? My target variable only 0 or 1. If you take multiple classifier, you can take that's the other question. So 0 or 1, right? So you have to achieve this result. You have to predict this 100 by values, 100 by 1 values. What it will contain here? 0 1 0 0 0 1 0 0 0 0 1 0 0, right? And here we have 3 columns. What are the column names? Let's take age. Okay, you can consider like this. Okay, height, weight. Okay, now here, yeah, after doing several things, let's open. I'll come back to this point again later. We'll talk. So let me move to this. So here, yeah, so I need to construct a hidden layer. Why? Because I'm transformed. So till now, what you have done, the way which you have done here is not satisfying the result. That means what? You are unable to achieve a good accuracy. That means you are failure in terms of applying machine learning concepts. The example what you have taken and you are applied several machine learning concepts, you are unable to get the result. When you feel that unable to get the result, when your accuracy is low, 60 or 70, and your error is very, very high, or if you are passing a regression technique, your error is very, very higher. If you are passing a classification technique, your error is accuracy is very, very low. These are the 2 possible cases. That means what? I need to apply this neural network structure, neural network here. So how it is going to happen? So here, indirectly, that means you are not going to pass or predict the result directly. You are going to construct a middle here, a hidden layer. Okay. Now the question is, what is the size of the hidden layer? Size of the hidden layer should be what? So initially you are constructing a hidden layer size. I mean, you are imagining. So always choose, it should be 1.5 times of your input. 1.5 times of your input. That means it is a recommendation, suggestible number. It's not a permanent number. Okay. So here I have already 3 columns. Okay. So here my hidden layer should comes out as a result as with 3 columns said na. So 3 double types. So how many columns? 400. Not getting na. See, 3 is your actual number. Make half to 3. What is your actual number? No, 1.5. If you half it, 3 will be because 1.5. All right, keep that 1.5. What is it? 1.5 times. What is 1 here? 3. 3 plus 1.5, 4.5. Understanding? So I cannot take the 4.5 number as columns or 4 columns. So that means what I need to take either 4 columns or I need to take the 5 columns. So I am choosing 5. Clear? Let's imagine that if my input is 100 by 2, okay, what is my hidden layer should be? If my input is 100 by 2, what is my hidden layer should be? 3, correct now? Because 2 means what? Half 1. You're already having 2, that plus 1, that becomes 3. Agree? Everyone agree? If my input is 5 columns, then what is the number of columns to be given in hidden layer? Tell me, guys. If my input is 5 columns, what is the suggestible number to be taken in the hidden layer? Yes, 7.5. That means either 8 or I can also go with the 7. Nothing wrong. Chetan, are you clear? Chetan and Sindhu are clear? Good. So here also we are taking such suggestible number. It's not mandatory, it's a suggestible thing that people will take. Okay. So here also we are taking those. So here that means what? 5 columns should be there. That means what? 5 neurons to be placed. So what happens in between here? Each neuron is going to connect with the respective of other neurons like this. Each neuron is going to connect with the respective of other neurons. The way how in your brain cells will be connecting this thing, na? Like this is going to be happen. So now I also need to take the second one like this. This is what happens actually. So you can imagine that how much a bigger architecture it is going to form here. So lot of lines now. I also need to take another line from here. Now imagine I just taken only 3 columns. If I take 100 columns, okay, if I take hidden layer as 150 columns, then what will be the structure? Just imagine. So why it is comparing with your brain? Able to understand? In your brain also will have lot of crores of cells. Okay, so each cell is getting connected with the other cell in the next, I mean whatever in the brain neural system. So here also each cell is connected with the next layer inputs what we have. If I have 100 columns, so you will have 150 columns. So lot of net calculation is gets happens. Now this is what called architecture. Okay, the same thing is also going to be happen even in this form here also. Even here also. Like this. The same thing is going to be happen here also. So this is I'm talking about one hidden layer. So this entire thing is what called a simple neural network, like mesh topology. My God, you are asking, is it comes under mathematics, mesh topology? I'm not remember about this mesh topology. Maybe it is there in your BTech, or you are talking about biology, computer science only, sir. Okay, I'm not aware of, because I'm not from the computer science background. I'm from the statistical background, na? So I cannot convert. I mean, I cannot make those computer science language here. But yeah, you can imagine it. You can imagine with your learnings wherever you see to get that properly digested. Okay, no issues. So simple neural networks, and yeah. So this is what happens. So imagine, yeah, if I have thousands of colors, so a lot of architecture is going to form. That is what actually the things. So here, now you are understood about this one, you are understood about this one, you are understood. So it is not going to come the result directly. Your X contains what, guys? Here, your X contains 100 rows into 3 columns. Your X contains 100 rows, 3 columns, and your H contains. So you have decided to take as 5. But where is the connectivity? What does it mean? You have to get the result from the X to fill your empty set of 100 by 5. You have created an empty set of empty structure of 100 by 5 hidden layer construction. But you have to pass your values from the original X. That is what it is going to be happen. So how this passing is going to be happen? This is 100 by 3 and this is 100 by 5. So here you have to apply mathematical matrix calculation method. The way how you have created coefficients, just a minute, on V line, just a bit. To get these values filled in your hidden layer, I need to apply matrix multiplication method. So what is that matrix multiplication method? The way, if you see back, how you are passing the coefficients, I also need to pass some coefficients here to similar to this, because my final result is what? 0, 1. I need to come back. So I cannot take my X values input, right? So I need to add up here a weight values matrix. Weight values matrix to be added here. Okay. Now the question is, how much to be added here? How much to be added here? So that my resultant should be comes out with the result as what? Hidden layer box. My hidden layer box contains what? 100 by 5. Okay. I need to fill the values with a 100 by 5 set of matrix values, right? So tell me what weight values to be calculated so that I can get a resultant of 100 by 5. So here it should be like this, guys. X into W, that gives my result as what? 100 by 5. Now tell me what I need to do in my W. What I need to give in the place of W so that my result should get was 100 by 5. Three by 5. Right now? Why? Because if we multiplied with 100 by 3 into 3 by 5, my resultant should be 100 by 5. That is what I need to suppose to get. That means what? I need to multiply with the W pi of matrix. W1, let's give it W1. Okay? 3 by 5 set of matrix. So 100 into 3, 3 by 5, that gives result as what? 100 by 5. So how this W1 values will get created? How this W1 values will be created? Randomly generated. Randomly generated values. Who will create? Your package. Your Python will create such values. In fact, or you have to give some values. If I do manually, I will use random integer, which is available in our Python functions. Those things will create a random values. If I make use of any package will create such values, initial values. Okay, initial values. Now this values 100 by 3 into 3 by 5 gives what result? 100 by 5 values. This is what now, what you have done, the activation function is ready with you. The activation function is ready with you. In this example, it will be displayed. Let me show you. Yes. All right, like this. Summation I equal to 1 to m wi xi. So what is wi here? Your weights. Your what is your x here? Your x1, x2, x3. Understanding? Now here, what is my result? 100 by 5, which is comes from the xw. On top of it, I will apply what? Any function which is available in our deep learning library. On top of this output, I will apply any function which is available in our deep learning library. What are the functions which are talking about in the previous? Yeah, like sigmoid, threshold, hyperbolic. Let me explain my page here. It was opened late, I could have explained here. And it is not here. Maybe the bottom. Like this. Your threshold function values will be around like this function. Okay. Next one is sigmoid. This is, you know it. E power beta x by 1 plus e power beta x. If I manipulate it, the answer will be like this. Now this is what? E power minus x. E power minus x means what? 1 by e power x. Right now? If I take this 1 by e near bottom e power x to the top, what will be remain? E power x divided by 1 plus e power x. That is what your logic thing, na? Actual sigmoid function is be like this. But if I convert it to inverse and put it back to your top now, those become your normal logic. All right. And rectifier, yes, this is what I'm talking about, max of x comma 0. Always your values will be between above 0 only. So it was negative, so it will be above 0 only. That is what this line makes it, tells us. Another one is what? Hyperbolic tangent. Hyperbolic tangent similar to your this one, 1 minus e power minus 2x divided by 1 plus e power minus 2x. Like that we have in mathematics, I say 10-15 functions are there, and many more is also there. I am also not sure, because mathematics is a subject of ocean. Okay. Yeah. So this is what I would like to explain in the functions. Now come back. So this is what I'm trying to construct now. Okay. So here, not here, here. Yes. So I'm applying a function. I'm applying a function. I'm going to get a values of h values. Those values will be placed in the exactly here now. Exactly here. Is it clear? So what? So how many weight values to be created? 3 into 5. 15 weight values are not. 3 by 5 set means what? 3 5 is 15 values. So if you count this thing, the number of lines which I drawn here will be 15 lines. Why? Because 3 here, 5 here. So obviously I could have drawn 15 lines. 3 into 5. Simple. Right now? 3 is your input. 5 is here. So I could have done definitely 15 lines. Simple logic. That means what? In each line, one W value will be passing out. Like this actually it happens. In each line, one W1, W2, like that, W3, W4, W5, W5, W6, up to W15. Where will be saved here? Here. 3 by 5. That means what? What is happening here? Age, let's say age is 25. 25 into one weight value from the 3 by 5 set. All right. Multiplied with here, and those will be applied on top of a function. So the given value will be, output will be some 0.23 or 0.5 or 175 or whatever. Like that, for all 100 rows, the values will be calculated with one W1 set. Is it clear? All 100 by 3 columns. I need to say like that. Yeah. All 100 by 3 columns will be multiplied with 3 by 5 with a matrix order calculation, and the result values will be saved as not saved. Result values will be converted in the form of 100 by 5. On those 100 by 5, you are applying what? A function. Okay. After converting actual function to, I mean, your input, sorry, after converting of your actual values to through the function, what the result will be comes out, those will be saved in your actual hidden layer. Is it clear now? Clear na? Very good. Now this left side portion is over. Now what is your input here? Now what is my input here? My hidden layer construction is my, becomes what? Input. Right now this becomes an input layer for what? This becomes an input layer for what? For your actual output. This hidden layer becomes an input layer for your actual output. Right now? Yeah. Now, so what is your actual Y values? 100 by 1. Okay. So here, I need to move it a little bit slightly here, because this is your actual Y. So you are trying to predict these values. So this is for just for your imagination. But what actually you will calculate? What actually you will calculate, guys? Tell me. Y predicted. Not Y na. Y means what? Actual Y values. So you have to suppose calculate what? Y predicted. Oh, yeah, it's gone somewhere. Okay, let's me put as y underscore t. All right. Okay, one second. Yes, now this will be better. So now what is your y underscore predicted values? What is the size of the y underscore predicted? What should be? 100 by 1, na? That means this box. So this also should be 100 by 1. 100 rows into 1. All right. All right. So do I will get the values 100 by 1 directly with the input of 100 by 5? Do I will get the values of 100 by 1 as output with the values of 100 by 5? No, na. So what I need to do again? What I need to do again? I need to add again a weight to matrix. Yes, weight to matrix. So what is the size? Yes, it should be 5 by 1. So here I need to supposed to be put yes with the. So I directly attached this thing here, but I should not directly attach. Yeah, so here it will be in middle. A weight 2 will be created. Here also I made directly attached without adding that weights multiplied values. But you just imagine. All right. So how much? So here 100 by 5, and it is 100 by 1. So definitely I need to create a weight values of 5 by 1. Right? That means what? If I multiply it with the hidden layer with W2, 100 by 5 into 5 by 1. So my resultant should be no y hat, na? Yeah, y underscore prediction. So should be got as 100 by 1. Of course, again what I need to do? Again what I need to do? I'll apply function. I'm not sure this result values will be more similar to my actual values or not. If it is more similar to actual values, then no need to apply function. Right? I may get a different values because I cannot believe on the randomly generated values. Na? Random generated values means what I don't know what it will take. So I need to apply a function to make more nearest to. That's how I'm making you recall of logit. What this logit is doing? It is trying to convert your actual values to nearest to your 0 to 1 values. In fact, strictly speak, it will be logit function will convert your actual values to between 0 to 1 values. Probability values will be created. 0 0.9, 0 0.8, 0 0.75 like that. That makes your error reduces less or not. That makes your error reduces less or not. That is a mathematical advantage that we are taking through the logit function or not. Agree? Similarly, we are also doing the same process on applying a function on it to get that mathematical advantage. Now you have your y predicted values, and now you have your y actual values. What is your y actual values? 100 by 1. What's next, guys? Now you should tell me. You're already known about it. What should I do next? Your predicted values, you got your actual values. What should be my next step? Okay, error. And then yes, finding error by comparing yn and y prediction. So what? Error in the sense, if it is a regression, you will find out error. If it's a classification, I have taken the example of classification here. Log loss. Log loss is also correct, or accuracy, na? I need to prefer either log loss or accuracy if I am taking the classification. If I am taking the regression, mean square error. Forgotten or what? If you give a gap in between your deep learning and supervised learning, we covered with the unsupervised learning. So you should not forget again. Okay. Yes. So finally, you are looking for these results. What are these things? No need to explain now. You are already aware about it. You are already aware about it. Now you have to concentrate on the things of what, how this architecture is getting created. How this architecture is getting created. This entire construction is what called simple neural network. Did I mention anything like that above? Not mentioned. All right. So we are supposed to learn few things. I thought I have mentioned there. In deep learning, we are going to cover few things. Simple neural network. Okay. Deep neural network. Okay. Convolutional neural network. Like this. Deep convolutional neural network. All right. So apart from this, we have something else also there, which is not in our syllabus, but you can look some Google book or any other thing. Okay, you can refer any books or any other thing. It's not an easy thing. Okay, which is called as recurrent neural network. Okay. Now, according to your concept, according to your syllabus and all, I know. Yeah, we need to cover up these things. These first 4 things. So writing this code will be very easy. No need to worry. Okay. So now you understood what is simple neural network is getting formed. Fifth also mentioned. Okay, let me check. We'll see. Okay. So here, come back. Yeah. So this is what called a simple neural network. Yeah, which is created. So here you are also required to understand 2 other things. What is feed forwarded and what is back propagation. What is feed forwarded method? What is back propagation method? Feed forward you already learned now. So how it is getting feed forward means what? Initially you are taking values with random values in creating weight values, and you are passing those values in the hidden. Again you are constructing a weight 2. Yeah. Again you are passing a weight 2. Again you are creating a randomly generated weight 2 values, and then you are applying and you are getting the result. So this is like one-way construction now. This is like one-way construction that is happening. Weight 1 value is creating and weight 2 value is creating, and you are achieving the result. So this is what called a feed forward method. But now the question is, when I'm saying that randomly weight values are getting created, now how should I believe that randomly weight values are makes our error less? How should I believe that my random weight values will also improve my accuracy? Randomly means what? I am giving a coefficient values of which my own. Now do you think that which I give of my own values in the weight values, that means on the beta coefficients. Let's imagine in the linear regression, if I apply my beta coefficients of my own, will your error will gets reduced? Will your accuracy improve the performance? Sorry, will your accuracy improves the values? No, na. That means the randomly weight values will be not finalized. Then what I need to do there? I need to rewrite your weight values again. I need to rewrite your weight values again. Rewrite in the sense replacing the weight values. So the question is, how you are replacing the weight values? With the error what you received at the end. So obviously in between y and y hat, that means y and y prediction, you will find an error values or not. On those errors you are working again on it. On those errors you are working again on it, so that you can recreate a weight values again in the W1 and W2. So for that purpose you have to apply your knowledge of what? Gradient descent algorithm. Understanding what I'm talking? You have to suppose to apply what algorithm? Gradient descent algorithm. Now you are already aware what is gradient descent. If you are forgotten, go through the book again. Sorry, go through my last video classes, what we have done. Gradient descent algorithm. So gradient descent algorithm will work on the errors and apply some derivative techniques, and it will recreate the weight 2 values first. After that, again weight 1 values. Again we rerun this thing from x to y hat. So when you go back and recreating this weight 1 and weight 2 values, now that theory comes under what? Back propagation. So that means what? With the help of gradient descent method, you are recreating your weight 2, weight 1 values again. That becomes what? Back propagation method. When you make again, when you recreated weight values and when you rerun it again you will get a y hat. Again you will see an error. Understanding? Again you will see an error. Again you will change those weights if your error is higher. That means that again you are working on back progression. That's why what happens? It's moving back. It's moving left to right, again right to left, again left to right, again right to left, left to right, right to left. Like that, it keeps on running this one. So how it is going to be happen? Through some number of iterations. That means you have to put everything into one loop. Understand my point, guys? You have to put everything under one loop. This loop will recreate the values again and again, applying gradient descent, and it will try to reduce the error again and again, again and again, till you get a minimized error, minimum loss error, whatever, minimized error. Yes, correct, minimized error. That is how it will do. So this entire process will work with one package called either TensorFlow or Keras. Understanding what I'm talking? Either through TensorFlow or Keras. Keras is more updated rather than TensorFlow. Clear? So that means what, you need to put up 100 or 1000 iterations to achieve the result. That means every time it will recreate the values of weights and it will regenerate the things, and it will keeps on running for 1000 or 100, how many times, 1 lakh, whatever. And you will see that for every 100 iterations or 1000 iterations, what is the error is getting dropped. You also need to verify, are your error is getting dropped or not. Otherwise, how you will decide error is dropping or not dropping? That is also be required. So this thing will be put into a batch. That means 100 iterations. Let's imagine that you are trying to pass 1 lakh times. I would like to see for 100 iterations, what is the error? For the next 100 iterations, what is the error? For 100 iterations, what is the error? So you need to put up everything into one batch. If you try to recollect the knowledge which I talked in the gradient descent, at the end, there are 2 or 3 different methods are there. One is mini batch method, stochastic gradient batch method, something is there. 3 different methods are there. So that methods, one method concept is talking about this one only. So for 100 iterations, I would like to, that means what, 100 iterations I need to put into one batch. Then what is the error? Again, next 100 iterations, how much it is reduced? That means what, batch under, I mean, for you are passing that 100 iterations into one batch. Again, next, that means what, same 100 iterations will be passed into again another batch. Like that, it will be keeps on converting the values. So how it is going to be happen, I just explained theoretically, but we'll talk in the coming classes. That at that moment you will see these things. Clear up to here? Okay. So let's recall today. When you have time now, you need to recall your gradient descent classes again, and let's come back with the story. Okay, so that you will connect it directly without interruption. All right. So let's stop for today. We'll meet again in tomorrow's class.